Hi everyone. So today I'm going to give the first lesson on limit, and this is going to be the one of the three lessons I'll talk about for limit. Limit is a fundamental part. It's a fundamental unit in calculus, and I should begin with giving you guys a definition of limit. So limit basically refers to the value that a function approaches when the input approaches a certain value. And the easiest way to teach you guys is to give you guys a function here. So I got a function of f of x equals to x cubed minus 1 over x minus 1, while x is not equals to 1. I got it here. X is not equals to 1 because you cannot have anything over 0, right? If you substitute x equals to 1 there, then it's gonna be 0 over 0, which is not gonna work. And the first way to evaluate this limit is just based on graph. So graphically you can see that at 1, f of x is undefined. However, when when x is approaching 1, as you can see, the function is actually 3. So the function is actually 3 when so f of x is approaching 3 when x is approaching 1. And the second way to help you guys to understand this is to use this table. So as you can see that when x is equal to 0.999, f of x is 2.97, and when x is 0.999, f of x is 2.997 here. And let's just ignore this here, ignore 1 here first. And when x is 1.001, f of x is 3.003, and when x is 1.01, f of x is 3.03. So as you can see that when the x is more, so the more x is closer to 1, the closer f of x is to 3. So yeah, so basically this limit of f of x when x is approaching to 1 means when x is approaching to 1, the function f of x is approaching 3. So basically it's this part approaching to 3. And this is like the really basic part about limit. And well, you will not have time to actually like do these tables or draw this graph in the exam, so you have to actually calculate the limit numerically by yourself. So let's still use this example here. F of x equals to x cubed minus 1 over x minus 1. Let's see more clearly. So actually, if you try to evaluate it, and as we said, that the function is going to be undefined, right? If you just do it like this. However, you can actually expand the f of x to this function here. Let's see, x minus 1, x plus 1 over x minus 1. And boom, you can cancel this out. So it's not, so when x is 1 now, it's just gonna be 1 squared plus 1 plus 1, which is equal to 3. So remember if you get like something undefined when you're doing limit, just try to expand the function and to cancel things out, and you will probably get a legit answer like this, like the example I shown here. So this So this limit f of x when x is approaching to 1 is just 3 here. And boom. So this is how you can do it numerically. And for another example, maybe, okay, so I'll give you an easy one. X squared plus 4. So sometimes you can just substitute the value in it. So it's just gonna be 0 cubed plus 4, which is equal to 4. You don't need to do this cancel out stuff there. So yeah. And another thing I want to show you guys here. Oh, and by the way, this is called a removable discontinuity. I'll actually talk about continuity later, but I just want to tell you guys here first that when you cancel something out in such limit situation, when you cancel something out and get a legit answer, it's called a removable discontinuity. Yeah. And another thing I want to show you guys is the composite limit. Let's just write it here. Composite limit. So the composite limit has a formula here. Limit x approaches to 3 of f of g of x. This is equal to f of limit of x approaches to 3g of x. So this equals to this, and sorry. So I'll just give you an example here as well. So when f of x is square root x and g of x is x plus 3, and limit x approaches to 1 of f of g of x. This basically means f of limit x approaches to 1 g of x. So if you evaluate limit of g of x when x approaches to 1, you're gonna get 1 plus 3 equals to 4, right? And you put f of 4 there, is square root 4, which is 2. And boom, you got the answer here. And the last thing I'll talk about today is two special trigonometric limit. Two special trigonometric limit. So the first one is this limit of sine of x over x when x approaches 0, and just remember this equals to 1. And you don't really need to know why for now. I'll show you how to get this result after you learn derivatives. But for now, just remember there's such a thing here. And for this, if you change sine of x to like sine of 4x over x, while the limit is still x approaching to 0, it's just gonna be 4. So it's gonna be like this top thing divide by this bottom thing. The top coefficient divided by the bottom coefficient. And the second special trigonometric limit is the limit of 1 over cosine x, 1 minus cosine x over x when x approaches to 0 is gonna equal to 0. And again, you don't really need to know how this is being retrieved, this answer. I'll tell you how to do this later when you learn derivatives using the L'Hopital rule. And in fact, I think you can you can actually prove these two formula here, these two equation here, without using derivatives, or without using calculus. But it's gonna be like really tedious, and it's gonna be like a really challenging. Not really challenging, but you need to do a lot of work, and you just don't need to know that for calculus. So for the sake of time, I'm just not gonna include that here. Yeah. Alright, and that's all for the introduction to limit, and I hope you learned something. Thank you.